Have you ever pushed yourself up from a chair and felt your legs tremble just slightly, like they weren't fully sure they could handle the job anymore? Maybe climbing a single flight of stairs now leaves you breathing harder than it used to. Maybe you've noticed your grip isn't as strong when you're opening a jar. Or perhaps you've caught yourself reaching for the handrail not out of habit, but out of genuine need. If any of that sounds familiar, I want you to know something important right now. You are not imagining it, and it is not simply just getting older. There is a very specific, very well-documented biological process happening inside your body, and once you understand it, you can actually do something about it. That process is called sarcopenia. It is the gradual age-related loss of skeletal muscle mass and strength, and it affects roughly 1 in 3 adults over the age of 65. It doesn't announce itself with a dramatic moment. It creeps in slowly, a little more fatigue here, a little less balance there, until one day simple movements that once required no thoughts suddenly demand your full concentration and effort. But here is what the mainstream conversation around aging almost never tells you. Sarcopenia is not a one-way door. Research over the past 2 decades has made it increasingly clear that targeted nutrition can slow muscle loss, stop it in its tracks, and in many cases, genuinely reverse it, even in people well into their 60s, 70s, and beyond. And the most powerful tool for doing that is not a protein shake. It is not an expensive supplement. It is not a prescription. It is a humble, widely available, affordable whole food that most people already have access to and many already eat, just not with the intention or consistency needed to unlock its full potential. In this video, we are going to cover exactly what that food is, why it works at the cellular and hormonal level, how much to eat, how to prepare it, what to pair it with, and what common daily habits might be quietly undermining all your efforts. By the end, you will have a complete, science-backed nutritional strategy for rebuilding and preserving your muscle, not someday, but starting today. Let's get into it. Part 1, Understanding the Enemy. What sarcopenia actually does to your body. Before we talk about the solution, it is worth taking a moment to genuinely understand the problem. Not in a frightening way, but in an empowering way, because when you understand the mechanism, the solution makes complete sense. Starting around the age of 40, the average person begins losing skeletal muscle at a rate of roughly 3 to 5% per decade. After the age of 60, that rate can accelerate to 8% or more per decade. By the time many people reach 70, they have lost anywhere from 25 to 40% of the muscle mass they had in their younger years, often without ever realizing it was happening. Now, muscle is not just about looking strong or being able to lift heavy things. Skeletal muscle is one of the most metabolically active tissues in the entire body. It plays a central role in regulating blood sugar. It protects your joints by absorbing impact and stabilizing movement. It generates body heat. It stores glycogen for energy. And critically, it is what keeps you upright, balanced, and independent. When you lose significant muscle mass, the consequences reach far beyond weakness. Balance deteriorates, increasing fall risk. Metabolism slows, making weight management harder. Blood sugar regulation worsens, increasing the risk of type 2 diabetes. Recovery from illness or injury becomes slower and more difficult. And the cumulative effect, the loss of the ability to do everyday things independently, is one of the leading drivers of reduced quality of life in older adults. So what drives sarcopenia in the first place? There are 2 primary mechanisms, and this is important to understand because the food we are about to discuss addresses both of them directly. The first is anabolic resistance. This is the technical term for what happens when aging muscles gradually stop responding to the normal biological signals that trigger muscle repair and growth. In a young adult, eating a moderate amount of protein reliably stimulates muscle protein synthesis, the process by which the body repairs and builds muscle fibers. In an older adult, that same amount of protein often fails to generate the same response. The signal gets weaker. The muscles become, in a sense, harder to reach. To overcome this resistance, older adults need not just more protein overall, but specifically the right kinds of protein, those rich in particular amino acids, especially one called leucine, which acts as a direct activator of the cellular machinery responsible for muscle building. The second driver is chronic low-grade inflammation, sometimes called inflammaging. This is a persistent systemic state of mild but ongoing inflammation that becomes increasingly common as we age. It is driven by oxidative stress, gut microbiome changes, declining hormone levels, and other age-related shifts. And it creates a biochemical environment that is actively hostile to muscle tissue, accelerating breakdown, impairing repair, and blunting the body's response to both exercise and protein. Reducing this background inflammation is therefore not just a general health goal, it is a direct, specific strategy for slowing and reversing sarcopenia. Keep both of those mechanisms in mind, anabolic resistance and chronic inflammation, because the superfood we are about to discuss targets both simultaneously through multiple distinct nutritional pathways. That is what makes it so remarkable. Part 2, the one superfood, chickpeas. The food is chickpeas, also known as garbanzo beans. I know. You might have been expecting something more exotic, something rare and expensive, imported from the mountains of some distant country. But the science does not care about glamour. And what researchers have consistently found inside the humble chickpea is a nutritional profile so well suited to combating sarcopenia that it is difficult to find a single other food that matches it across so many dimensions at once. Let's go through exactly why chickpeas work, layer by layer. Protein quality and leucine content. 1 cup of cooked chickpeas, approximately 164 grams, provides around 15 grams of plant-based protein. That number alone is meaningful, but what matters more than the quantity is the quality and composition of that protein. Chickpeas contain all 9 essential amino acids, the ones your body cannot manufacture on its own and must obtain from food. Among those 9, leucine is the one that deserves special attention in the context of muscle loss. Leucine is not just a building block for muscle tissue, it is a direct molecular signal. When leucine levels rise in the bloodstream following a meal, they activate a cellular signaling pathway known as the mTOR pathway, mechanistic target of rapamycin. This pathway functions like a master switch for muscle protein synthesis. When it is activated, your cells receive a clear instruction: stop breaking down muscle and start building it back up. In younger adults, this switch is fairly easy to flip. In older adults, as we discussed, it becomes sluggish due to anabolic resistance. The threshold of leucine required to activate it rises. This is exactly why not just any protein source will do. You need food that delivers leucine in sufficient quantities to clear that higher threshold. Chickpeas, particularly when combined with complementary proteins as we will discuss shortly, provide that. Magnesium and muscle function. Chickpeas are an excellent source of magnesium, providing approximately 79 milligrams per cup, roughly 20% of the daily recommended intake for older adults. This mineral is involved in over 300 enzymatic reactions in the human body, and a significant number of them are directly tied to muscle function. Magnesium is required for muscles to contract and, just as importantly, to relax. When magnesium levels are insufficient, muscles have difficulty releasing tension after contraction. The result is the kind of persistent tightness, nighttime cramping, morning stiffness, and restless leg sensations that are extremely common in older adults, and very frequently caused or worsened by mild, unrecognized magnesium deficiency. Multiple studies have linked low dietary magnesium intake in older adults to reduced grip strength, slower walking speed, and decreased physical performance on functional tests. And correcting even a mild deficiency through food rather than supplements, which are far less bioavailable, often produces noticeable improvements in how muscles feel and respond within a matter of weeks. Iron and oxygen delivery to muscles. Chickpeas contain approximately 4.7 milligrams of iron per cup, covering roughly 26% of the daily recommended intake for men and postmenopausal women. Iron's relationship with muscle health is indirect but absolutely critical. Iron is required to form hemoglobin in red blood cells, the protein responsible for carrying oxygen from your lungs to every tissue in your body, including your muscles. When iron is insufficient, hemoglobin production falls, red blood cells become less effective, and your muscles receive less oxygen with every heartbeat. The practical result is fatigue that arrives faster than it should, weakness during activities that once felt easy, and a general sense of being run down that many older adults attribute simply to age when it is, in fact, at least partly nutritional. There is one important note about the iron in chickpeas. It is non-heme iron, the plant-based form, which is not absorbed as efficiently as the heme iron found in animal products. However, vitamin C dramatically enhances non-heme iron absorption by as much as 60% in some studies. This means that something as simple as squeezing lemon juice over your chickpea dish or eating them alongside tomatoes or red bell peppers can more than compensate for the difference in bioavailability. We will come back to this in the meal planning section, resistant starch and the gut-muscle connection. This is where chickpeas truly distinguish themselves from nearly every other food in the conversation about muscle loss, and it is the part of the science that most people have never heard about. Chickpeas are rich in resistant starch, a form of carbohydrate that resists digestion in the small intestine and travels intact to the large intestine, where it becomes food for your gut microbiome. The beneficial bacteria that colonize your colon ferment this resistant starch and produce compounds called short-chain fatty acids, the most important of which is butyrate. Butyrate has been the subject of growing scientific interest over the past decade. Research published in journals including Cell and Nature Metabolism has shown that butyrate plays a direct role in maintaining and even restoring muscle mass. It does this through several mechanisms. It reduces systemic inflammation. It improves insulin sensitivity in muscle tissue, which directly addresses anabolic resistance. And it appears to activate genes associated with muscle fiber maintenance and growth. This pathway, from gut microbiome health to muscle integrity, is sometimes called the gut-muscle axis, and it represents one of the most exciting frontiers in nutritional science. What it means practically is that when you eat chickpeas regularly, you are not just feeding your muscles directly through protein, you are also feeding the microbial ecosystem in your gut in a way that creates a systemic environment more favorable to muscle retention and rebuilding. No protein powder can replicate this effect. Anti-inflammatory phytonutrients chickpeas contain meaningful amounts of kaempferol and quercetin, two plant-based flavonoids with well-documented anti-inflammatory and antioxidant properties. Recall the second major driver of sarcopenia we discussed, chronic low-grade inflammation. These compounds work directly against that process. Quercetin, in particular, has been studied for its ability to inhibit inflammatory cytokines, signaling molecules that promote tissue breakdown, including in muscle. It also reduces oxidative stress in muscle cells, which is one of the primary mechanisms by which aging accelerates muscle fiber degradation. Including foods rich in quercetin and kaempferol in your regular diet is not a dramatic intervention, but as part of a consistent nutritional pattern, the anti-inflammatory effect accumulates meaningfully over time. Folate for cellular regeneration. Finally, chickpeas are one of the richest dietary sources of folate, vitamin B9, providing approximately 71% of the daily recommended intake in a single cup. Folate is essential for DNA synthesis and repair, and that means it is essential for the creation of new cells, including new muscle cells. Muscle regeneration in older adults is dependent on the activation and proliferation of satellite cells, specialized muscle stem cells that repair damaged fibers and contribute to the formation of new ones. This process requires folate. When folate is insufficient, cellular regeneration slows, and the body's capacity to repair and rebuild muscle declines. Many older adults are folate deficient without knowing it, and that quiet deficiency can silently undermine all other muscle-building efforts. Part 3. How to eat chickpeas. For maximum results, knowing the food is one thing, using it correctly is another. Timing, preparation method, and pairing strategy all influence how much benefit you actually extract from chickpeas, and it is worth being specific about each. How much for meaningful muscle protective effects? Research suggests targeting 1 to 1.5 cups of cooked chickpeas per day, either in a single serving or split across 2 meals. This provides a consistent supply of leucine, magnesium, resistant starch, and folate across the day, rather than a single large dose that the body may not fully utilize. Timing for older adults in particular, distributing protein intake evenly across the day produces better muscle protein synthesis outcomes than loading most protein into a single meal. Your body can only utilize a certain amount of protein for muscle building at any given time. The rest is oxidized for energy. By spreading chickpea-based meals across lunch and dinner, for example, you give your muscles two separate anabolic signals rather than one large one. The protein pairing strategy chickpeas, like most legumes, are high in the amino acid leucine but relatively lower in methionine. To create a more complete and effective amino acid profile for muscle building, pair chickpeas with foods that complement this gap. Whole grains such as brown rice, quinoa, oats, or whole wheat bread are higher in methionine and create a complementary amino acid profile when eaten alongside chickpeas. This does not need to happen in the same meal. Eating complementary proteins throughout the same day is sufficient for the body to assemble complete profiles for muscle synthesis. Eggs and dairy add high-quality complete protein that amplifies the muscle-building signal from the leucine in chickpeas. A bowl of chickpeas alongside a poached egg or a serving of Greek yogurt creates a nutritional synergy that exceeds what either food would provide alone. Preparation methods: canned chickpeas are nutritionally comparable to home-cooked dried chickpeas. Rinse them well under cold water to remove excess sodium, then use them directly. No cooking required. This makes them one of the most genuinely convenient whole food protein sources available. Roasted chickpeas are made by patting canned chickpeas dry, tossing them in a small amount of olive oil and your choice of seasoning, and baking at 200 degrees Celsius, 400 degrees Fahrenheit, for 25 to 30 minutes until crispy. They become a satisfying, high-protein snack that can replace processed snack foods entirely. Hummus, made by blending chickpeas with tahini, lemon juice, garlic, and olive oil, is one of the most nutritionally intelligent ways to eat chickpeas. The tahini, sesame paste, contributes methionine to complete the protein profile. The lemon juice provides vitamin C to enhance iron absorption. The olive oil adds heart-healthy monounsaturated fats that support the absorption of fat-soluble vitamins. It is, essentially, a nutritionally optimized chickpea preparation hiding in plain sight. Added to soups, stews, and curries, heat does not significantly degrade the protein content, resistant starch, or mineral content of chickpeas. They absorb the flavors of whatever they are cooked with and add bulk, creaminess, and nutrition to virtually any savory dish. Part 4. The supporting foods that amplify chickpeas' effects. Chickpeas are the foundation. But a truly effective nutritional strategy for reversing muscle loss is not built on a single food in isolation. The following foods work in direct synergy with chickpeas and with each other, each targeting a specific aspect of the Sarcopenia equation. Whole eggs, yolk included, hold a unique position in nutritional science. They have a biological value of approximately 100, the highest of any whole food, meaning the body can utilize nearly all of the protein they provide for tissue building. This is not true of protein powders, which go through high heat processing that denatures some of the protein structures and strips away the naturally occurring cofactors that assist absorption. The yolk is where most of the micronutritional value lives. It provides vitamin D, which is required for normal muscle function and is deficient in the majority of adults over 60, particularly those with limited sun exposure. It provides choline, which supports the nerve-to-muscle communication pathway, the signaling system your nervous system uses to recruit and fire muscle fibers. It provides vitamin B12, which maintains nerve integrity and is essential for the coordination and balance that depends on healthy neuromuscular function, and it provides heme iron in one of the most bioavailable forms available from any food. A clinical study from the University of Illinois followed older adults who ate 2 whole eggs with breakfast every day for 8 weeks. By the end of the study, participants showed measurable improvements in walking speed and lower body strength compared to a control group. That is a functional real-world result, not just a change in a laboratory number. Kefir is a fermented milk drink with a tangy flavor, originating from Eastern Europe and the Caucasus, where populations consuming it regularly have historically maintained notable physical vitality into old age. Modern research has begun to explain why. Kefir contains up to 60 distinct strains of beneficial bacteria and yeasts, a probiotic diversity that surpasses all other dairy products and most supplements. But its value for muscle health goes well beyond general gut health. Kefir is uniquely rich in casein protein. Unlike whey, which is digested rapidly and delivers a quick spike of amino acids, casein forms a slow-digesting gel in the stomach and releases amino acids gradually into the bloodstream over a period of 5 to 7 hours. This makes kefir consumed before sleep extraordinarily valuable for older adults. While you sleep and fast for 8 to 10 hours, your muscles are vulnerable to protein breakdown. A glass of kefir before bed essentially maintains a steady supply of amino acids throughout the night, reducing that overnight muscle loss. Additionally, because kefir's protein has been partially pre-digested by the fermentation process, it is easier to absorb, particularly for older adults who may have reduced production of stomach acid and digestive enzymes, which commonly impairs protein absorption with age. Canned wild salmon, a standard can of wild-caught pink or sockeye salmon, provides approximately 25 grams of complete protein alongside one of the most bioavailable concentrations of EPA and DHA omega-3 fatty acids found in any food. These long-chain omega-3 fatty acids have a specific and well-documented effect on aging muscle. They increase what researchers call muscle anabolic sensitivity, meaning they make muscle tissue more responsive to the protein-building signal, triggered by leucine and the mTOR pathway. In practical terms, when you regularly consume adequate omega-3s, the same amount of dietary protein produces more muscle protein synthesis than it would otherwise. Multiple large studies have found that older adults who regularly consume omega-3-rich fish retain significantly more muscle mass and functional strength than those who do not, independent of total protein or calorie intake. Canned salmon also contains soft, edible bones that are an excellent whole food source of calcium, phosphorus, and vitamin D3, the form of vitamin D that is biologically identical to what your skin produces when exposed to sunlight, and the form most effectively used by muscle tissue. Unlike calcium supplements, the calcium from salmon bones is gentle on the digestive system and does not carry the cardiovascular concerns associated with high-dose calcium supplementation. Beets occupy a unique niche in the muscle support conversation because their primary mechanism is not protein-related, it is circulatory. Beets are the richest dietary source of inorganic nitrates, which the body converts through a series of enzymatic steps into nitric oxide, a molecule that signals the smooth muscle lining of blood vessels to relax and dilate. This increases blood flow to skeletal muscles by up to 20%, delivering more oxygen and more nutrients while simultaneously clearing away metabolic waste products, including lactic acid, which contributes to the soreness and fatigue that follows activity. Studies examining the effects of beet consumption on older adults have found improvements in muscle efficiency of approximately 16%, meaning subjects could perform the same physical work with measurably less fatigue and less muscle damage. For someone over 60 who wants to remain active and functional, this is a profound benefit. Beets also contain betaine, a compound that donates methyl groups in key metabolic pathways, including the body's natural synthesis of creatine. Creatine is stored in muscles and used as a rapid energy source for short, high-intensity contractions, standing up quickly, catching your balance, climbing stairs. Its production declines significantly with age, contributing to the loss of quick-response muscle strength that makes falls more common. Eating beets regularly helps naturally restore some of that creatine synthesis capacity. Parsley. Most people treat parsley as decoration, a green garnish to be pushed to the side of the plate and forgotten. That is a significant nutritional mistake. Fresh parsley contains approximately 130 milligrams of apigenin per 10 grams, a flavonoid with potent anti-inflammatory properties that has been specifically shown to calm inflammation within muscle tissue. Given what we know about inflammaging and its role in driving sarcopenia, this is directly relevant. Apigenin also appears to support satellite cell activation, the muscle cells responsible for repairing damaged fibers, making parsley a genuinely functional food for muscle recovery and regeneration. Parsley is also one of the most concentrated sources of vitamin K found in any common food, over 600 micrograms per 100 grams. Vitamin K is required for the activation of proteins that regulate calcium in the body, directing it toward bones and muscles rather than soft tissues. It also supports the muscular contraction process itself by activating muscle-specific proteins that require it as a cofactor. Adding a small handful of fresh parsley to a chickpea dish, blending it into a smoothie, or stirring it into soup requires virtually no effort and delivers a consistent anti-inflammatory, bone and muscle supporting nutritional contribution every single day. Part 5, a practical daily meal plan. Here is how all of these foods can come together into a realistic, enjoyable daily eating pattern. This is not a rigid prescription. It is a framework. Mix and match based on what you have available and what you enjoy. Morning, within 30 to 60 minutes of waking 2 whole eggs, scrambled or poached in a small amount of olive oil with a side of vegetable, whatever you have on hand. Spinach, tomatoes, bell peppers, mushrooms. If you have fresh parsley or chives, add a generous handful. This gives you complete high-quality protein, vitamin D, choline, heme iron, and anti-inflammatory phytonutrients before you have even started the day. Mid-morning snack, a small bowl of plain, unsweetened Greek yogurt with a tablespoon of chia seeds and a handful of fresh or frozen berries. The Greek yogurt provides slow-digesting casein protein and calcium. The chia seeds add omega-3 fatty acids, magnesium, and additional fiber. The berries contribute antioxidants that fight oxidative stress in muscle tissue. Lunch. The chickpea anchor meal, a chickpea bowl with brown rice, roasted red bell peppers, cherry tomatoes, cucumber, a generous handful of fresh parsley, and a dressing of olive oil and lemon juice. This single meal covers your leucine requirements, your resistant starch and butyrate production, your iron intake boosted by the vitamin C in the peppers and lemon, and a full complement of anti-inflammatory phytonutrients. It is also genuinely satisfying and easy to prepare in advance. Afternoon, after any physical activity, a wedge of fresh watermelon or a glass of fresh watermelon juice. Watermelon is the single richest dietary source of citrulline, an amino acid the body converts to arginine and then nitric oxide, improving circulation to muscles still recovering from activity. Research has found that watermelon consumption can reduce post-activity muscle soreness by up to 40% and accelerate recovery time significantly. Dinner, canned wild salmon or sardines in olive oil. Both are convenient, affordable, and nutritionally complete. Pair with roasted beets, which can be prepared in large batches and refrigerated for the week, alongside a serving of steamed sweet potato and a side of any green vegetable. This combination delivers complete protein, omega-3 fatty acids for anabolic sensitivity, nitrates and betaine from the beets for circulation and creatine support, and complex carbohydrates from the sweet potato for steady overnight energy. Before bed, a small glass of plain kefir, roughly 150 to 200 milliliters. The slow-digesting casein will maintain a steady supply of amino acids to your muscles throughout the night, directly counteracting the overnight protein breakdown that is one of the underappreciated contributors to progressive muscle loss in older adults. Part 6. Mistakes that quietly accelerate muscle loss. You can eat all the right foods and still undermine your progress if you are making any of the following common errors that frequently go unrecognized precisely because they seem harmless. Skipping breakfast or eating only simple carbohydrates in the morning. After a night of fasting, your body is in a mildly catabolic state, leaning toward breaking down tissue for energy. The first meal of the day sets the metabolic tone for everything that follows. If that meal is white toast, juice, or nothing at all, you are extending the catabolic period and missing the most important protein delivery window of the day. A blood sugar spike from simple carbohydrates, followed by a rapid crash, also creates the hormonal conditions that promote muscle protein breakdown. Discarding egg yolks. This habit, born from decades of misguided advice about dietary cholesterol, removes the most nutritionally valuable part of the egg. The yolk contains vitamin D, choline A12, iron, and the unique protein complexes that make whole eggs superior to isolated protein sources in multiple clinical studies. Current evidence is clear. For most people, including older adults, Dietary cholesterol from whole eggs does not raise cardiovascular risk and may actually support the production of anabolic hormones, including testosterone, that are essential for maintaining muscle mass. Relying on instant flavored oat products. Many commercially packaged oatmeal packets contain 12 to 20 grams of added sugar per serving, more than some desserts. Sugar in this quantity promotes systemic inflammation, raises blood sugar sharply and then crashes it, and directly interferes with protein metabolism. Steel-cut or old-fashioned rolled oats with no added sugar, customized with chia seeds, berries, or a small amount of natural honey if desired, deliver all the blood sugar stabilizing and anti-inflammatory benefits of oats without the damage. Treating protein powder as equivalent to whole food protein. Protein powders are processed products. Most commercial whey or plant-based powders undergo high heat extraction processes that damage protein structures and strip away the vitamins, minerals, enzymes, and phytonutrients that make whole food protein bioavailable and effective. Multiple studies directly comparing whole food protein with protein supplementation in older adults have found that whole foods consistently produce superior muscle protein synthesis outcomes. The supplement industry spends billions communicating the opposite message. The research does not support it. Eating protein only at dinner. This is perhaps the most widespread dietary pattern working against muscle preservation in older adults. Many people eat a light breakfast, a modest lunch, and then a large protein-heavy dinner. But muscle protein synthesis is limited by how much leucine the body can process at a single sitting to activate the mTOR pathway. Eating 60 grams of protein at one meal does not produce twice the muscle-building stimulus of eating 30 grams. Distributing protein across multiple meals, morning, midday, and evening, gives your muscles multiple stimulation windows throughout the day and is consistently more effective for older adults in research settings. Muscle loss does not have to define your later years. The biology of aging is not fixed and unchangeable. It is responsive to what you eat, when you eat it, how you move, and how consistently you provide your body with the raw materials it needs to maintain and rebuild the tissue that keeps you strong, stable, and independent. Chickpeas are not a miracle. They are something better, a reliable, affordable, evidence-backed food that addresses the root mechanisms of sarcopenia through multiple pathways simultaneously. Combined with whole eggs, kefir, wild salmon, beets, and a few simple herbs and vegetables, they form the foundation of a nutritional strategy that your muscles can genuinely respond to. You do not need to change everything overnight. Start with one meal. Add a cup of chickpeas to your lunch this week. Swap your breakfast toast for 2 whole eggs. Pour a glass of kefir before you go to sleep tonight. Small, consistent changes made with the right foods and the right understanding of why they work. That is what turns the biology around. Your muscles are waiting for the signal. Give them one.